Conversions of number system. Before going to deal with this topic, let's have a brief discussion about number systems. Number system. There are four types of number systems. As we have already known in the intermediate, there are binary is represented by B, octal O, decimal D, hexadecimal HD. The radix basis, that means the base is the binary for the radix. The base for binary is 2, the octal is 8, the decimal is 10, the hexadecimal is 16. The possible numbers, here we have two numbers. The numbers will be starting from 0 and ending with 1. That means only two values, 0 and 1. 8 means 0 to 7. 10 means 0 to 9. 16, here we have only 9 values. From the 10th value we will represent as the alphabet 0 to 9. From A to F, here A means 10, B means 11, C means 12, D means 13, E is 14, F is 15. Up to 15 values we will represent the numbers as the alphabets. For example, in the binary form we will represent as 0101 to the base 2. If the base is 2, that is binary form. If the base is 8, then it is called octal. In the name itself, the octal. Octa means 8. The binary, the name itself, the binary means 2. In the decimal, 297. The base 10. Base 10 is decimal. Hexadecimal 2AC. The combination of numbers and alphabets is called hexadecimal with a base of 16. These are the types of number systems. Now let me describe the conversions of number system. What are the conversions of number system? Conversions of number system. We have several types of conversions. They are binary to decimal, binary to octal, binary to hexadecimal, octal to binary, octal to decimal, octal to hexadecimal, decimal to binary, decimal to octal, decimal to hexadecimal, hexadecimal to binary, hexadecimal to octal, hexadecimal to decimal. These are the conversions of number system. Here in this video, let me discuss some of the conversions, that is binary to any conversions, decimal to any conversions. Let us consider an example 23.42 to the base 10. This is a decimal conversion. In this video, let me discuss a decimal conversion to any conversion, decimal conversion to any conversion. 23.42 to the base 10. That means base 10 is equal to binary form. Converting of decimal in this video, converting of decimal into binary and decimal into octal, octal into hexadecimal. First, decimal to binary. Decimal to binary. We have considered an example 23.42 to the base 10. in this decimal to binary, in any conversion of decimal to any conversion, in this first the step is to do LCM. Before going to do the LCM, let us remind this is integer part. The left side of the point is called integer part, the right side of the point is called fractional part. It is fractional part or a rational part. LCM 23 with the base 2, because the binary form of the base is 2, so 2 11s are 22, remainder is 1. 2 5s are 10, remainder 1. 2 2s are 4, remainder 1. 2 1s are 2, remainder 0. So we here take from the top down approach, that is 1 0 triple 1, 1 0 1 0 triple 1. So for the LCM 23 to the base 10 is equal to 1 0 triple 1 base 2. So now let me convert this into binary form. Here the some steps are involved: multiplying the fractional value and note down the integer. When we have to find the rational part, keep integer part as 0 and multiply with radix. Here already we have the 23, so keep it as the integer part as 0.42. Here the base, the conversion of for the base is 2. Now multiply with 2, here we get 0.84. the value in the integer part is remained as 0. We will take the integer part as 0. Next, the resultant value in the next step, the resultant value will be taken. 0.84 into 2 is 1.68. The integer part is 1. Next, we will skip this integer part and we will write the fractional part, which is 6.68, that is 0.68 into 2 is 1.36. We will take up to 3 values, so we will write 10.011. This is how we convert decimal into a binary form. Now let me explain the another conversion, the decimal to octal conversions. Now let me take a brief example. Before going to consider an example, the decimal base is 10. Here to convert decimal into octal, consider an example 123 to the base 10. Now first we should convert this number into octal value. So the octal value base is 8. So 123, we will do LCM with 8. 15 8s are 120, remainder is 3, and 8 1s are 8, remainder is 7. So the number is 123 to the base 10 is equal to top down approach 173 to the base 8. This is how we will do the decimal to octal. Here we don't have any point values. In the previous example we have the point values. Now let me consider the point values. 245.25 to the base 10 to octal conversion. Same as it is 245 base 8, as octal have the base 8, so we will do 8 as the LCM. 240, remainder 5, 8 3 is 24, remainder 6, 365 to the base 8. So here we have 0.25, so 0.25 into 8 is equal to 2.0. The multiplication is 2.0. The integer part number is 2. here we have double zeros, so 0.00, anything number 0 is 0. So in the next step, in the next following steps, we will get all the zeros. So here we will stop the value. Now the final answer is 365.20 to the base 8. This is the final answer for the decimal to octal. This is how we convert the decimal conversion into octal conversion. Now the next topic is decimal to hexadecimal conversions. The decimal, the base is 10. The here used to convert the decimal into hexadecimal. Now let me consider example 245.25 to the base 10, here to convert into hexadecimal. So the base is 16, so we will do LCM with 16. LCM is 15, the remainder is 5. So as I already said, 15, A is 10, B is 11, up to 9 only decimal values will be obtained. From A 10, B 11, C 12, D 13, E 14, F 15. So here we got 15 as F value. So we will take top down approach, bottom up approach. 15 is F, so F 5. Here in this, here we will take 0.25 value, 0.25 into the decimal value is 16. Here we will multiply 4.004. As I already previously said that 0.00 as we will take or not neither take is that up to your wish. 0.00 equal to 0. So here this is the answer, F5.40 to the base 16. This is the final answer for the octal to hexadecimal. This is how we convert the octal into hexadecimal. Let me consider another example. 234 to the base 10 to the base 7. Same as if we get the base 7, base 2, we have base 2, base 8, base 10, base 17, base 16, sorry. Here now we are dealing with a decimal into any conversions. So here we get only 7. So for dealing this problem, we will consider an example to the base 10 and base 7. We will do example, we will do LCM with 7. Here remainder is 3, 7 4 28, remainder 5, 4 5 3. Here got we will get answer 234 to the base 10 is equal to 453 to the base 7. This is how we will convert decimal into any conversions like binary, decimal, hexadecimal. Thank you. See you in the next video.